authorized access, unauthorized. For unauthorized access, red LED. For authorized access, green LED. This is an experiment to interface RFID reader with Arduino UNO board. And we have used two RFID tags here for this experiment. And the connection, how to make the connection. This is Arduino UNO board and this is RFID reader, card reader. And here we have used 7 pins, and the middle one is IRQ pin that we have not used. And this is SDA pin. The first pin is SDA pin. SDA stands for serial data. So this is connected to pin number 10 of Arduino UNO board. And pin number 9 is connected to RST pin of Arduino UNO board. RST pin of RFID. It is connected to pin number 9 of Arduino UNO board. Next, orange one. There is a third pin, that is second pin, SCK. SCK stands for serial clock. The serial clock is connected to pin number 13 of Arduino UNO board. And the third one is MOSI. MOSI stands for master out serial in. So in here, this system is using SPI interface system, that is a serial peripheral interface. So in serial peripheral interface bus, there is master slave relationship will be there. The Arduino board is acting as a master and the RFID reader is acting as a slave. So the orange line, it is master out. It means the Arduino board is sending data to the RFID reader. So MOSI stands for master out and slave in. So the slave is receiving the data, master is sending the data. And the fourth one is MISO. This is master in, slave out. Master in means the data is coming from RFID reader to Arduino UNO board. Master in means towards Arduino UNO board the data is moving. So master in, slave out. And the next is ground pin of one pin you have to keep open, that is IRQ pin. Next, the ground pin of RFID reader is connected to ground pin of Arduino UNO board. And next, this is RST pin. The RST pin of Arduino UNO RFID reader. It is connected to pin number 9 of the Arduino UNO board. And the last one is pin 3.3. The 3.3, it is connected to 3.3 volts of volts pin of Arduino UNO board. So this is about the connection. The next step is to connect two LEDs, green LED and a red LED. We are using green LED to indicate the authorized access and red LED to indicate the unauthorized access. So whenever we swipe the authorized tag, RFID tag, it means the UID number which we write it in a program. So when we swipe that, then green LED will blink. And when we swipe the unauthorized tag, whose number is not there in our program, so it will display as access denied. For this purpose, we are connecting two LEDs. The cathode of green LED is connected to ground, and the cathode of red LED is also connected to ground. The anode of green LED is connected to pin number 6. And the cathode of red LED is connected to pin number 7. So this is all about the connection. This project we can use, project or experiment we can use for access control system, where we can create a door lock system that it only grants access to the authorized users with RFID tags. And in attendance system also we can use this system. It develops an attendance tracking system for schools or offices where students or employees use RFID tag to register their attendance. And it also uses smart home applications to create smart home access system using RFID tags to control the opening and closing of the door. So this is all about the applications, and the code I have already I will explain later. So this is all about a connection diagram of interfacing of RFID reader with Arduino UNO. Now, in order to indicate the authorized access, and one more is what condition we have taken, access denied condition, we are using two LEDs. For authorized access, we are using green LED to indicate, and for access denied, we are using red LED to indicate. Red LED anode, it is connected to pin number 7 of Arduino UNO board, and green LED anode is connected to pin number 6 of Arduino UNO board, and the cathode of green LED is connected to ground here, and the cathode of red LED is also connected to ground, and the ground is connected to ground terminal of the RFID. So this is about connection. Now when we swipe the authorized access card, so which LED should glow? Green LED should glow. So let us try that. See, it is blinking. So green LED is blinking because we are swiping the authorized access card. Now we will swipe the unauthorized access because this number we have not given in a program. So we will swipe the unauthorized access. So it is showing red LED. So the red LED is blinking when we swipe the unauthorized access card, and when we swipe the authorized access card, because we have given the number in program, authorized program code, UID code we have given in a program. For that purpose, green LED is glowing. So once again we will try. After uploading program to Arduino UNO board, so go on the right side, right corner, click on serial monitor and adjust the baud rate 9600, because you have written 9600 baud rate in your program. Select this. So now it is asking you to use the card, approximate your card to the reader. So we will go near the RFID card reader. Now she is keeping her RFID card near the reader. Okay. So now it is giving us the UID number 235786A9 and giving the message as access denied. So why it is giving access denied? Because in program I have given the card number as F9D1F36E, but the card what I am using is 235796A9. For that purpose it is giving access denied. Now we will copy this card number, Control C, and we will paste it in program, Control V. So again we will download the program, upload the program, go to tools, select port as COM3 because my Arduino board is connected to COM3 port, and select the board. To select the board you have to go to Arduino AVR board, under that you select the Arduino UNO board. Now you upload the program. So it takes 1 or 2 seconds of time to upload the program. Here it is showing done uploading and done uploading. Now we will swipe the card again. Yes. Okay, now after giving the correct UID number in a program, and it is displaying as authorized access. Authorized access. unauthorized. For unauthorized access, red LED. For authorized access, green LED. In this experiment, we should include two libraries, SPI and MFRC522 libraries. So first we should click on Sketch and include library and click on Manage Library. And here you type SPI. So it will show you many options. Here I have already installed SPI by Adafruit. If you install, it will show you like this option. Otherwise, you install it. I have already installed it. And we should install one more library file that is for our RFID card, MFRC522. So I'll type here MFRC522. When I click here, again, I'll get many options here. Which one I have installed, I'll show you. MFRC, SPI, I2C, UART. This I have installed already. So you also install it. So these two you should install before executing this program. Sometimes SPI will come as inbuilt function in this Arduino IDE software. In that case, you need to install only MFRC522 library. So this is the way of including the two libraries. So the SPI, this library provides functions for communications with the device over the serial peripheral interface bus. SPI stands for Serial Peripheral Interface Bus. It is commonly used for communication between microcontroller and the peripheral devices. So the microcontroller here used is Arduino UNO board, and the peripheral device is RFID reader. So in order to do communication between microcontroller and RFID, this SPI will help. That is a serial peripheral interface bus will help us to do the communication. And the second one is MFRC522. This library is especially for MFRC522 RFID readers. As I am using MFRC522 RFID reader in my project or in my experiment, so this library I should include, and this will this library is especially for MFRC 522 RFID reader module. It provides functions to interact with RFID cards. Okay. Then hash define SS10, SS pin 10 and RST pin 9. So this defines the slave select. So here in SPI communication, there will be a master-slave relationship will be there. Here the master will be the Arduino board and the slave will be the RFID. This will act as a slave. The RFID will be acting as a slave. So for that purpose, I'm using pin number, I'm defining pin number 10 for the slave pin. And to reset, I'm using pin number 9. So these two I am defining. Okay, next this one, this line, MFRC522, SS pin, comma, RST pin. This will initialize and, for example, in case of object-oriented programming, we will have a term called as instance. So it will initialize the instance of MFRC522 class with specified slave select. We have selected the slave as a RFID reader and the reset pins. For that purpose, this pin is used. Next, we are using the pin mode instruction command to make pin number 7 as a output pin and pin number 6 as a 6 is also output pin, because for pin number 7 and pin number 6, we are connecting LED. For that purpose, these two pins we are making as a high pair, high. And then to initialize the serial communication, we need to define serial.begin 9600. So this specifies the baud rate. For that, we can check the message in a serial monitor. So we should give the baud rate as 9600. Next, initialization of SPI dot begin. It indicates that it initializes the SPI bus, and this one it initializes the MFRC522 module. So these are the few instruction you need to know, and remaining all no need to study. Only what are the connection you are doing, that much you should know. And after initialization everything, you will get a message as approximate your card to the reader. So in the, see here in the serial monitor, I am getting as approximate your card to reader. So after that, we will swipe our RFID tag. When we swipe, then it will check whether immediately when we swipe, it will give the UID tag number. So after getting the UID tag number, you should copy that UID tag number and paste here. So where we should paste? This is the place where we should place 235786 A9. So if you use another tag, then it will give another UID number. That if you don't want this, you can paste that card UID number also. And so when I swipe the card with this number, it will print the message as authorized access. So see here, I swiped the card, same tag, and it is giving as authorized access. When I swipe the other number card tag, so for example, this 8354 8F and A6, since I have not copied here, it is giving as access denied. So in this way, you should copy the code and paste it there. So once if you want to show the output in LED when the card is authorized access, then you can send hi to the pin number 6 where you have connected a LED. It will start blinking. So for every 200 milliseconds on off, every 200 milliseconds on off. In this way, if it is authorized access, green LED, we are connecting to pin number 6, it will start blinking. So for access denied, we are connecting LED to pin number 7. So the pin number 7 where we have connected red LED, the red LED starts blink. So 1 means high. After 200 milliseconds, 0 means low. So LED will become on. After 200 milliseconds, LED will become off. Again, after 200 milliseconds, LED will be on. After 200 milliseconds, LED will be off. In this way, we will blink the red LED. So this is all about the program. So after this, you should upload your code. So how to upload the code? So before uploading your code, go to Tools and select the COM port and select the Arduino UNO board. Then you upload the code. So for uploading, you just click on this option. So it will upload your code to Arduino UNO board.